So today we're going to talk about relays. It's a very important part in electronics. So the use cases for relays are like they can control multiple circuits. So if you have like C1 and C2, like you can control both of them. And the advantage is that C1 and C2 are completely electronically isolated. So it's very good. And you just need a low current for C1 to like control C2, for example. So that's the second point. And now let's like take a look inside the relay. So let's say this. Okay, so we also have mechanical and solid state relays similar to hard drives and SSDs. So mechanical relays actually have like moving parts inside the thing, so electromagnets. And solid states is like there's no moving parts and it's electronical. So today we're gonna take a look at mechanical relays. So inside there's obviously, as you heard, electromagnet coil. So this is basically a solenoid, and when electricity passes through it, current, it creates a magnetic field. So it acts like electromagnet. So electromagnet, and so then we obviously like want to like have some magnetic force which attracts it to like contact it for like the circuit. And for that we like, so first of all, this is like a fulcrum kind of thing. Wait, I think I should have. Okay, so something like this is like one contact pad. So this is like one circuit, basically A and B we can call it. So this is normally closed and this is normally open. So basically what it means is that when nothing happens, so when it's just when the thing is powered, the relay is powered, and we don't do anything, we don't give any input signal, it's just gonna stay this. So this circuit is gonna be like high. So this is touching. I mean, there's also a spring, so it makes sense. So when you actually pass current through this, basically the input signal, like input current, so it acts like a magnet, it attracts it, so it pulls this down, the armature down, and it contacts this, but also this moves to the right and it contacts NO. So this path, this is B, for example. And now the normally closed, let's name this A and B, A, B. So now A is not going to be in contact, but B is going to be in contact. So that's why it's called normally closed and normally open, because when you don't provide an input signal, normally this A is going to be in contact and B is not going to be in contact. So that's why it's normally closed. And normally open, similarly, it's the same thing. And so this is how relays work inside. So let me tell you the pins. So usually there are 3 pins. So for this coil kind of thing, so there's obviously the normally open, there's COM, and there's normally closed. This is not for the coil, this is like the output kind of thing for the controlling the circuit. And there's obviously for the coil alone, there's plus, positive, minus, which is ground, and the input signal S. So this is for the coil. So positive and negative should be connected, obviously, but so ground basically. So, and this is the input signal. So if this is high, it's gonna come in contact, and B is gonna be closed. So basically, if you provide an input signal, the normally open, which is B basically, and the COM, which is common, like it's basically named, it's short for common. So normally open and common are gonna like, circuit is gonna be closed. And if the input signal is low, which means like no current provided, normally closed and COM is gonna be like having a circuit. So you can pass or like control circuits. And now we can look at the example circuit. So we have, using a breadboard, so we have a 5 volts, we have a 9 volt battery, we have a 5 volt power supply, we have a relay. This is the mechanical relay, and we have two LEDs. So we use two to show like both the circuits, so one for the normally open and one for the normally closed. In this case, the red LED is the normally closed one, because if you see the wire, I've connected it to normally closed NC, and the blue LED I've connected it to normally open, and the COM is just positive in this case, and I've connected both the LEDs to ground. And this is the input signal. I connected this and this to positive and negative respectively. And now if I turn it on, it's on obviously because it's normally closed. Now this is the input signal and this is the positive. So if I put it inside one of these ports, it should turn the red LED off and the blue on. So if you see, there's a signal LED, SMD. So, and you can also hear the click sound of the armature touching the electromagnet. So if I insert it